Alright, so it says Mayuko is sitting 30 feet high in a football stadium. So you can imagine yourself, if you're in a football stadium, you're high. Yes. Yeah, okay. I'll show you a paper and then we'll go down. Okay? So we're just doing the one because Alex. Okay? So it's sitting 30 feet high in a football stadium. So you guys been to like the Coliseum? I know you guys do the Coliseum. So you're 30 feet high, okay? Or if you go to Staples Center, okay, 30 feet high. And then the angle of depression to the center of the field is 14 degrees. Okay? Good story, bro. Okay? Oh. Alright. So he's in the stadium, right? So let's say you're sitting here. Remember, we're gonna set up the horizontal line, right? The horizontal line, this is where you are. The little dot. Technically in the stadium, you do live that small. So right? And I remember the angle of depression is going to be 14 degrees, so that means I'm going to do 14 degrees in this way, right? So I'm going to create that segment, okay? And so this right here is the center of the stadium. Center, and of course, is the end. Okay? I'm watching the clippers, I'll do the action. Alright, so what can we do here? So what can we do here? Okay? So now think of this is the center of the stadium, right? So now this is the ground. Okay? So this is another segment, right? Okay? And so remember, I made the horizontal line, right? I made the horizontal line. Okay, so that one. Who's the So remember, we make the horizontal line, and that horizontal line has to be parallel to the floor, right? Okay. So I'm gonna make a triangle here. Okay. It's a right angle. We're gonna make a segment perpendicular to it, right? Okay. So this is my picture now. Okay. I went from having all those ugly words right there to that beautiful picture with me and happy face, right? So now, what can you tell me about angle 14? I have 14 degrees here, right? Okay. What happens when I have two parallel lines cut by a transversal? So what is that called? Alternate interior angle, right? So I have alternate interior angle, so I know this angle here is also 14. Okay? Right? So remember, this is my angle of depression, right? Right here. Because of that, because of the fact that I have parallel lines here, cut by a transversal, this angle and this angle are congruent. Okay? So what am I looking for here? I want to find the horizontal distance between me, in this case, the center of the field. So what am I looking for? I'm looking for this segment. Segment X, right? Okay? Now, it says that I'm sitting 30 feet high. So what's going to be, is this going to be 30 or is this going to be 30? This one, right? Yes. Okay, that's high. Okay, yes. Okay, so Juan, before you give me the answer, how did you set it up, Juan? Well, we're solving for this distance, right? Because I want to know how far, if I'm watching a basketball game, I want to see how far I am from.
So yeah, like I was mentioned on Friday, they were confusing the horizontal distance being this distance instead of being the hypotenuse.
Okay.
Because horizontal.
Yeah. Horizontal distance, yeah, that's a transversal, right? So horizontal distance is going to be a transversal. Okay. All right, Alex, answer here, please. Okay. So if I want to watch the Lakers, I want to watch the tip-off. Okay, the Lakers. Who's the Lakers fan? Okay, that's what you're Hey, they beat the Thunder yesterday. I go for the Clippers.
They
All right.
Yeah, the cheerleaders, Mr.
Too much makeup.
All right, let's go back to the ball now. All right, so let's say Victor wants to know how far away he's from the cheerleader. Right? So how are we gonna set up this problem? How are we gonna set up this problem? Cosine of what?
66 degrees.
So you're using 66 degrees. Where did you get 66 degrees from? So you're using this angle?
Oh, you use the right angle or the 14?
You use the 14, right? Okay. But let's okay. Eyes up here, please. Now, would this one really be 66 though? Let's use our calculator. What would that be? What must this angle be right here?
Oh, yeah, right, it will be 70.
It would be 76, right? 76. So that's why it's better to use the angle that they give us, okay? Because you make, I don't know how to count either, so I would make that mistake too, you know? So I rather use the angle they give me instead of making up my own angle. Okay? So I'm gonna use 14. Okay? So I have 30 is it opposite or adjacent to 14? Opposite. And then I have here what's x?
Oh, wait, X.
X is the hypotenuse. Okay? So if I look at SOHCAHTOA, what can I use? SOHCAH or TOA? Sine, right? We use opposite of hypotenuse. So I'm going to say sine of 14 degrees.
Teachers in their grades.
Listen, I do this. Sine.
But I was wondering.
Sine. And that's opposite, which is 30. 30 over x. Okay? So sine of 14 degrees equal to opposite over hypotenuse, right? So 30 over x. Okay? And then we're going to multiply by x. Multiply this side by x. And that side by x. Okay? So I have x times sine of 14 degrees. That's equal to 30, right? My x is here on the right cancel. Okay?
I'll show you.
Then remember, sine of 14 degrees, that's a ratio, right? It's an actual number, so I can divide by sine of 14. I'm going to divide by sine of 14 degrees. Okay? So then we use our handy dandy calculator. Okay? 30 divided by sine of 14. 124 feet. Per meter, feet.
I'll put the